Fruit thinning, according to the U.S. Department of Agriculture Cooperative Extension Office, is the single most important management strategy in determining the annual profitability of apple orchards. A successful apple thinning program reduces the number of fruits per tree, resulting in larger apples at harvest, and provides a number of additional benefits to the grower. But hand thinning is inefficient, it's prohibitively expensive, and it requires ladder work, which can involve safety concerns for workers. That's why chemical thinning is generally the preferred method. One of the most commonly used chemical thinners is liquid lime sulfur. For nearly 2 decades, liquid lime sulfur, or calcium polysulfide, has been used as an insecticide, a miticide, a fungicide, and as an apple blossom thinner in the Pacific Northwest. Its success has also led to the product being labeled for this purpose in several eastern states. In fact, a recent survey conducted by the Washington Tree Fruit Research Commission reveals that about 60% of all apple acres in Washington are being treated with liquid lime sulfur. In this video, we'll cover the benefits of lime sulfur as an apple blossom thinner and its modes of action. You'll see a demonstration of the personal protective equipment that applicators are required to wear, and we'll address the issue of drift management, including the 6 steps for ensuring a successful lime sulfur application. Tori Schmidt is an expert on the topic of apple blossom thinning. He's a project manager for the Washington Tree Fruit Research Commission, based in Wenatchee, Washington, where he's worked for the past 25 years.
The focus of my research has been on crop load and canopy management, focusing primarily on the use of plant growth regulators and chemical thinners in tree fruit production. I grew up in Western Washington in a timber community. My dad was a forester. Went to school, met my betrothed in college, and she's from orcharding history. Her parents owned a pear orchard in Dryden area, the Wenatchee River Valley, and we moved over here after we were married in hopes of taking over the family orchard once they retired. And in the meantime, I figured I needed to learn some more about the tree fruit industry, so I took courses at Wenatchee Valley College, and later I got a master's at WSU in horticulture and got a job at the Tree Fruit Research Commission in crop load and canopy management and have been working there ever since. Blossom thinning can be an important component of crop load management for apple trees. And the earlier you can start on your thinning, the better the results will be in terms of improving your harvest fruit quality, harvest fruit size, and improving your return bloom. So where you have the opportunity to apply a chemical blossom thinner, that really gives you a leg up and a head start on your job of crop load management. One very interesting outcome of our work with lime sulfur as a chemical bloom thinner is that once it was registered in the state of Washington, we saw a clear impact on statewide production. Whereas prior to lime sulfur being registered, prior to 2004, the state was in a very clear biennial bearing pattern. Large crop one year, small crop the next year, large crop the next year, and so on. Once industry started adopting lime sulfur in 2004, those curves really flattened out, and the annual swing from one year to the next was much less pronounced, which benefited not only individual growers, but the statewide marketing effort that had a much more consistent crop year in and year out to sell. There are potentially 4 modes of action in which lime sulfur is effective as a chemical thinner. First, we know that lime sulfur can damage the stigmatic surface of flowers such that when pollen is deposited on the stigmas, whether by bees, winds, or whatever vector, they are unable to successfully germinate and the flower never becomes fertilized. A second potential mode of action of lime sulfur is that it can be absorbed through the sides of the style, so that if you have a flower that's already been pollinated and pollen tubes are growing down the length of the style towards the ovary, lime sulfur can actually kill and arrest those pollen tubes as they're growing, which prevents fertilization, and then you won't get an apple. A third mode of action for lime sulfur involves photosynthetic stress that may be induced by lime sulfur, especially for an application in conditions that are warm and dark, where a tree may already be experiencing some photosynthetic stress. Lime sulfur can increase that stress such that the tree goes into a negative deficit for carbohydrates and then needs to abort some of its crop load in order to preserve the remaining fruit for the rest of the season. A potential fourth mode of action for lime sulfur as a chemical bloom thinner would be that lime sulfur can damage pollen from the pollinizer, so that when it gets deposited on flowers of your apple tree, those pollen grains are no longer viable. There's not much direct evidence of this, but there's some initial research indicating that this may be occurring. In chemical thinning research, we look particularly towards three key economic indicators that our thinners are making money for their growers. First, we want to see thinners that reduce fruit set so that growers don't need to spend so much money to green hand fruit thin their crops mid-season. Secondly, the fruit that remains should be larger and of higher quality to increase the growers' packouts. And thirdly, the block that's been chemically thinned should have a better return bloom because of an effective chemical thinning job earlier in the spring. Through the years, we've been able to establish that the use of lime sulfur can also help reduce the incidence of powdery mildew in apple orchards. And we did a study with a collaborator at Washington State University indicating that an apple grower who applies 2 sprays of lime sulfur during bloom could actually drop out 2 of their fungicide applications and still get the same level of control. We've also heard anecdotal evidence that lime sulfur can help hold down populations of some arthropods, including mites, early in the season, which could have potential implications for integrated mite control as well. In an ideal situation, with temperatures, let's say in the 50s and 60s, which would be typical for that time of year, bloom might be somewhat protracted, and there might be a week to 10 days where a grower has an opportunity to put on 2 or possibly even 3 chemical bloom thinning sprays. The first 2 sprays generally would be targeted to the entire tree where flowers are open. Later in bloom, the bloom may be petering out in the lower parts of the trees, but you still have fresh flowers in the tops of the trees. So that third application might be targeted just to the tops of the trees. However, we do have springs that are quite hot with temperatures that might reach the 80s or in some cases even the 90s. The bloom window gets compressed down to a much shorter period, say 3 or 4 days, and the grower might only have a chance to get 1 spray on before bloom is finished. We have evaluated a number of different types of oils in our research through several years of field trials. We began primarily focused on fish oil because we knew that to be effective in some organic growers' situations. That proved to be very effective, and through the years we also included the use of a number of petroleum or mineral oils, including both summer and winter oils. They all worked well. We also evaluated some vegetable oils. Overall, we probably tried 10 or 12 different oils, and they all partnered well with lime sulfur. Of course, there's always the potential to have some oils that aren't well refined or maybe are not reputable. So the oils that we've evaluated were commercially accepted, high-quality horticultural spray oils. So in this graphic, we see a summary of every chemical bloom thinning trial that we've done at the Washington Tree Fruit Research Commission for the last 20 plus years. It includes data on our 3 most important parameters for chemical bloom thinning. First of all, does the chemical thinner reduce fruit set so we don't have to spend so much money on green fruit thinning? And we see that lime sulfur and lime, sulfur, and oil programs outperform everything else that we've worked with. Likewise, with harvest fruit quality, we've seen more increases in fruit size with lime sulfur and oil and lime sulfur combinations than any other bloom thinner we've evaluated. Return bloom is often overlooked because it's not something that's immediately observable, but it is key to a grower's economic bottom line in ensuring that they can produce an annual high-quality crop year in and year out.
Before applying lime sulfur, it's extremely important to know and understand the precautions you must take in order to protect yourself and the environment. Liquid lime sulfur is corrosive and can cause irreversible eye damage. It causes skin burns and is harmful if swallowed or absorbed through the skin. Do not get the product in your eyes, on your skin, or on clothing. After handling the product, wash thoroughly with soap and water, especially before eating, drinking, chewing gum, using tobacco, or using the toilet. Now, let's take a look at the required personal protective equipment, or PPE, that every mixer, loader, applicator, and other handler must wear when using the product. Start with a long sleeve shirt and long pants. Then, add a set of coveralls over the long sleeve shirt and long pants. Chemical-resistant gloves are required. Gloves should be cuffed about 1/2 to 3/4 of an inch and tucked under the sleeves. Add chemical-resistant footwear over a pair of socks. The pant legs of the suit should always cover the boots. Next, apply goggles or a face shield. Make sure there is chemical-resistant headgear to protect against overhead exposure. Some applicators also choose to add an additional layer of protection with chemical-resistant pants and a chemical-resistant overcoat with a hood as a best practice. Finally, a chemical-resistant apron is required when mixing, loading, or cleaning equipment or cleaning spills. And although a respirator is not required, wearing a respirator is considered to be a preferred best practice. Remember, always be sure to discard and never reuse clothing and other absorbent materials that have been drenched or heavily contaminated with this product's concentrate. Follow the manufacturer's instructions for cleaning and maintaining your personal protective equipment. If no such instructions for washables exist, use detergent and hot water, and always keep and wash your PPE separately from other laundry. For other safety recommendations, refer to the product label. A variety of factors can influence pesticide drift, including weather conditions like wind direction, wind speed, temperature, relative humidity, and the method of application like ground, aerial, air blast, or chemigation can influence product drift. The applicator and grower must evaluate all factors and make the appropriate adjustments when applying lime sulfur. Jeff Robinson is an expert in the matter of spray drift management in the state of Washington.
My name is Jeff Robinson. I'm an educator with the Technical Services and Education Program through the Pesticide Management Division for the Washington State Department of Agriculture. And today I would like to share with you a little bit of information about pesticide management, how we can control pesticide drift. Off-target drift is the movement of pesticides from the sprayer that are assisted by air to areas that are beyond the target or beyond the trees. Anytime that we are targeting or we're doing an application, we want to make sure that our applications are on target. Some of the repercussions of off-target spray drift are damage to the environment, damage to surrounding habitat, animals, whether it's domestic or wildlife. Our neighbors can suffer from that as well in the fact that the pesticides land in their yards or on their homes, affect their animals or their children, and it can be damaging to other crops where that pesticide was not meant to be applied. As pesticide applicators, we are responsible for our pesticide applications. When they're not on target, we waste pesticides we can damage the environment. Those pesticides are very expensive, and to get them on target, to get the maximum use for what they're intended for is very important. When we blow past our target, we're wasting money. We're having nozzles that we're not turning off that are shooting where there are no trees, no target area. We go to the end of the row, we don't turn our sprayers off, they're still on. It's off target. We're wasting resources as well as damaging the environment and hurting wildlife. One of the most important ways to mitigate or manage off-target drift is to ensure that your sprayers are calibrated and configured appropriately. An accurate calibration will make sure that you're applying the desired amount of pesticides to the target area. Configuring your pesticide spray equipment will make sure that it is on target, that we're not shooting pesticides above or below the target area. Reducing our air intake will help us when we don't have full foliage to make sure that we're not blowing past our target. And basically we will increase our deposition on the target area. By nature, air blast sprayers are prone to drift, but there are steps that we can implement to mitigate this off-target drift. I would like to speak with you about 6 basic steps we can take to calibrate and configure our air blast sprayers to mitigate drift. Step 1 is to check your tractor speed. Do not assume that your speedometer is correct. There are many factors that will alter the speed of your tractor, such as the composition of the soil, the slope that you're working on. The accuracy of your speedometer can change over time. The equipment that you're using to apply can change the speed of your tractor. So what you want to do is you'll want to measure a distance and then see how long it takes you to travel that distance. And with some mathematical calculations, you can accurately determine the speed of your tractor. There are other tools, other applications on your phone or GPS that can assist with that as well. Step 2, we really want to visualize where the air is going. To assist us in doing this, we tie ribbons to the nozzles. This will allow us to see where the air is going and where the spray is going to end up. This helps us to know which nozzles we need to close. And we also want to remember to use our air deflectors. This will help us keep our pesticides on target. Step 3, we want to match the air with the size and shape of our canopy. To do this, we will tie some ribbons to the outer edges of the tree. We should see a slight flutter. If we don't see ribbon movement, we don't have enough air. If we see that the ribbons are sticking straight out, we have too much air and we need to reduce our air. Some strategies to reduce the amount of air in our air blast sprayers are things like we can gear up and throttle down, decreasing the RPMs while still maintaining the speed of our tractor. That'll slow the fan down, less air. Another strategy that we can do that's been very effective is we can take a burlap sack, and using that burlap sack we can cover the air intake. That will decrease the amount of air that's coming into your sprayer and make sure that you're not putting out too much air blowing past your target. Remember, anytime you do anything that will affect the speed of your tractor, you need to recalibrate your spray equipment. Step 4, calculate gallons per minute. To do this, you need to consider the number of nozzles you will be applying with as well as your tractor speed. There are applications that can assist you in coming up with these calculations. However, it is important to corroborate this information with your calculations to ensure that it is correct. Step 5, measure nozzle output. Using water, we want to make sure that each nozzle puts out the correct amount. We will then add up the nozzles to make sure that it is the desired amount of product per acre. Using hoses along with flow meters makes this an easier process. Remember, use water for these calculations. Once this has been done, you can start to apply product. Step 6, verify coverage. To do this, we will use water-sensitive paper. Placing water-sensitive paper at various heights and locations within the tree canopy, we will make a pass with the sprayer using water. After we've made our pass, we can pull the water-sensitive paper down, take a look at it to assess our coverage, and make any adjustments that are needed. These 6 steps will provide a solid foundation for you to perform effective pesticide applications. There are other factors that can affect your pesticide application: weather, poor maintenance, poor operator training, applicator attitude, equipment condition. These all play an important factor in an effective pesticide application. WSDA offers an on-site air blast sprayer technical assistance service. We will work with your individuals that are responsible for calibrating your equipment to make sure that they are doing it the appropriate way. We will go out to your farm utilizing your equipment to train your employees in this process. We will walk through all of the 6 steps to calibrate and configure your air blast sprayer. Plus, we'll give you some additional tips and tools on how to improve your pesticide applications. This free training is a wonderful way to make sure that your pesticide applications improve. Plus, for those that are applicators, we offer recertification credits. WSDA offers a day-long course in calibrating and configuring air blast sprayers. We will walk through the 6 steps in calibrating and configuring your air blast sprayers. This will greatly assist you in performing proper pesticide applications. There are a couple of other great resources available. A couple websites we recommend are agr.wa.gov and sprayers101.com. In Washington State University has some great resources available, and you may also want to check out your local county extension offices.
To summarize, liquid lime sulfur delivers many benefits as an apple blossom thinner. It's an important component of crop load management. It improves the quality of fruit at harvest, and it improves return bloom. The product can also deliver other benefits as an insecticide, a miticide, and a fungicide. Wearing personal protective equipment is required when mixing, loading, applying, or handling liquid lime sulfur. A full explanation of the proper PPE can be found on the product label. Remember, product stewardship is critical. Be mindful of spray drift management practices to protect your surroundings and the environment. Finally, be sure to read the label thoroughly and know the risks. When using liquid lime sulfur, use common sense, take precautions, follow all directions, and you'll increase your chances of seeing the results you're seeking at harvest time. Liquid lime sulfur is labeled for use as an apple blossom thinner only in certain states. Refer to the label for application rates, restrictions, precautions, personal protective equipment, and states where use is permitted. For more information, contact your local NovaSource representative or visit NovaSource.com.